Hi everyone, today I'm going to show you the heating solution that I decided to install in my shipping container house. And in this video, I'm going to explain how I installed this product, but most importantly, why I chose this heat pump to heat my house, compared to other heating systems such as a pellet stove. Alright, let's go. I'm Julian Malara and this is my container house. I'm 26, have no do-it-yourself experience, but challenged myself to build an affordable, eco-friendly house. I'm also trying to develop my resilience and live in harmony with nature. I'm filming everything for this channel, so subscribe to follow the adventure. Let's begin. What is a heat pump? A heat pump is very simple. It's a heating system that uses the outside air to heat the inside air. The system is pretty simple. Outside your house, you have a unit that absorbs the heat energy present in the air, and it uses that to heat a refrigerant fluid that is extremely cold. The Aldes T-Air heat pump operates even when it's minus 15 degrees outside, because the refrigerant fluid is so cold that it evaporates even at minus 15 degrees. The outside air's heat causes the liquid refrigerant to warm and become a gas. As soon as it's above minus 15 degrees, this gas is then compressed, which increases its temperature, and this heat is transferred into your house through an air distribution system, radiators, or underfloor heating. For T1 air, air will be distributed via a suspended ceiling. Once the heat has been removed from this gas, it cools down and returns to a liquid state. And then the cycle can start over again. A quick note in case it's colder than minus 15 degrees. Your heat pump will still keep working because there's an electric heater that takes over in case it gets too cold. It won't be as efficient as the heat pump, but you'll still have heat. If you live in high mountain regions like Canada, where it's often below minus 15 degrees, the heat pump system might not be the most suitable for you. I recommend discussing this with your thermal engineering office, as they will advise you on the heating solution. The process I showed you is very effective. The most efficient heat pumps generate up to 5 times the energy they use. In other words, a heat pump will use up to 5 times less electricity than a conventional electric heater. And the icing on the cake is that this cycle can be reversed, which means that instead of taking the heat energy from outside and transferring it inside, you'll take it from inside and transfer it outside. So a heat pump can provide both heating and air conditioning. I showed you an air-to-air heat pump, but there are also air-to-water ones. They'll heat a water tank so you can use the hot water in the shower, bathtub, and more, or supply your other radiators. It's an interesting solution, especially for renovations. Now that you've seen how a heat pump works, you probably understand that it's one of the most environmentally friendly and economical heating systems. I'm reading these two parts on purpose, because if you use less energy to heat your home, it will reduce your electricity bill, but also your environmental impact. Let's go a bit more into detail about how much a heat pump costs in terms of energy consumption. I don't live in my container house yet, so I don't have exact data. However, my thermal engineering office did a simulation and estimated that I should consume about 250 euros of electricity per year to heat my 116 square meters. Thanks to the T1 Air, that's very little, and I'll explain why. My 6 kilowatt T1 Air has a seasonal performance coefficient of 4.2. That means that with 1 kilowatt hour of electricity, it can produce 4.2 kilowatt hours of heating. For comparison, a standard electric heater has a 1-to-1 ratio. That means to produce 1 kilowatt hour of heating, it will need 1 kilowatt hour of electricity. The T1 Air from Aldes is 4.2 times more economical and efficient than a standard electric heater. We can also note that it has a seasonal energy efficiency ratio and indicator similar to the scope. But for cooling, it's 6.2. That means with 1 kilowatt hour of electricity, it can produce 6.2 kilowatt hours of cooling. For comparison, the portable air conditioners you can use at home have an average coefficient of 2.6, which means that the T1 Air is 2.5 times more efficient and effective than a standard portable air conditioner. For any new construction today, you must comply with Real Estate 2020, the 2020 environmental regulations. It's important to pay attention to these coefficients, like seasonal performance coefficient or seasonal energy ratio, because you are required to use heat pumps that are very energy efficient. It's worth checking out Aldes, as their heat pumps are among the most efficient. And even if you're renovating, it's very important to pay attention to these coefficients. Because the higher the heat pump's seasonal performance coefficient or seasonal energy efficiency ratio, the more energy efficient it will be, and the lower your electricity bills will be each month. So it's still very interesting. So we can conclude that a heat pump is one of the most efficient systems for producing hot or cold air. As I said, I'd pay $250 a year for heating instead of over $1,000 with regular electric radiators. Compared to a pellet stove, another notable heating option in real estate, 2020. Heating my 116 square meter house would cost about 250 euros in pellets per year. That's the same as the electricity for the heat pump. But the big advantage of the heat pump is that I can produce my own electricity with solar panels, so I can reduce the cost of the energy I'm going to use. Producing wood pellets is more complex. Quick side note, right now I'm thinking about the sizing of my solar installation. Based on my calculations, with nearly 3,000 watts of solar panels, I should be able to generate all the electricity I'll use in this house each year. So it's a pretty easily achievable goal, and of course I'll make several videos about it for you. To finish this part about energy consumption, it's interesting to look at the energy performance diagnosis. According to my thermal engineering office, my heat pump, thermodynamic water heater, and excellent insulation make this possible. Watch our videos on the topic. I actually have great insulation. Normally my house shouldn't use over 40 kilowatts per square meter each year, which is an A rating. For reference, A+ is for passive houses, and anything below A is progressively worse. And if I manage to produce 100% of my electricity with solar panels, I'll have a positive energy house. I'll show you all that in upcoming videos. Now that we've reviewed energy costs for a heat pump, pellet stove, and other heating options, let's examine maintenance costs, starting with the heat pump. Maintenance is simple. Change the filter once a year to maintain indoor air quality. This filter costs 60 euros and is very easy to change yourself. And since July 2020, you need to call a professional once every 2 years to come and check that the system is working properly. You'll need to pay 150 euros there. For the pellet stove, you need to pay a professional about 150 euros each year to clean it and check it's working properly. So when you compare maintenance costs for a heat pump and a pellet stove, they're basically the same, give or take a few dozen euros. There's not a big difference. However, remember that a heat pump needs no daily maintenance. Whereas with a pellet stove, you constantly have to add pellets, check that it's not too dirty, and clean it. It needs more daily work than a heat pump. Now let's discuss the heat pump's price. In any case, it's not something you can buy and install yourself. You will definitely have to go through a professional installer who will buy all these supplies from specialized distribution stores. For a heat pump like the T1 Air, you should expect to pay around 9,000 to 10,000 euros, including supplies and installation. Because it's eco-friendly, you're eligible for financial aid. That's only if you're doing renovation work. You only get MAP Prime Renov for the RO packs, but unfortunately not yet for the models offered by Aldes. And you also have the energy saving certificates, which are compatible with the T1 Air and other similar heat pumps. I won't focus on subsidies, as there are many and each has specific criteria. If you're doing renovations, where do you live? What's your income? There are too many criteria for me to list all existing subsidies. I suggest you research them yourself. 9,000 to 10,000 euros is a significant initial investment. I agree with you, but you have to look at it more from the perspective of long-term savings. With the heat pump, my monthly electricity bill will be much lower, saving me money over time. It's even more interesting if you're renovating, since subsidies lower the investment cost. And compared to electric radiators or old heating systems that we currently have in our homes, it will save you a lot of money. You'll pay 4 to 5 times less on your electricity bills compared to now. The initial investment for a pellet stove saw a very interesting heating solution. From the perspective of the year 2020, it will be closer to 5,000 euros, so almost half the price of a heat pump. That's something to consider, but I still chose the heat pump, and I'll explain why. Let's talk about wood pellets. This winter, we all saw shortages and a sharp price increase. Even though the price of electricity will very likely go up and we might face rationing, I still feel more resilient. With an electric heating system then, which can be powered by solar panels compared to pellets that I can produce myself much less easily. The second reason is that I'm kind of lazy. Well, I'm not super lazy, but it still annoys me. Having to refill my pellet stove every 2 days, carry 15 kilo bags, buy and store them, and clean the stove every 2 or 3 days. Well, no, all of that compared to a heat pump where I just say 18 degrees Celsius and it's 18 degrees Celsius. It's comforting, but still a reason to consider. Third, you must consider that my heat pump can supply all rooms in my house via the suspended ceiling system. Whereas with my pellet stove, it would have been more complicated to bring heat to each room. It's often paired with traditional electric radiators, which I think makes it less appealing. And the icing on the cake, I've already mentioned it. You might see where I'm going with this. In summer, when it's 40 degrees Celsius, my well-insulated house is well positioned. Normally, it won't get too hot, but still, it can help cool things down. And for very, very little energy. As we said, there's a coefficient of 6.2. So I'll use very little electricity to cool my house a little, which is already very well insulated. The pellet stove can't do that, so it's a luxury once again, but that matters too. I think we've pretty much covered the arguments in favor of a heat pump compared to other heating solutions. Now I'll show you how I installed everything and if it was complicated. Let's start with the supply plenum first. In other words, the drywall false ceiling. This is often the part that scares installers, but it's actually not very complicated. I first started by building a drywall closet to house my indoor unit, and from that closet I extended my drywall false ceiling. Aldes calculates all vent dimensions and placements. I insulated the false ceiling walls facing empty space with a new insulation called Libris Actis. It's not very expensive, very efficient, easy to cut, and above all, it folds. So, it makes it easy to place it between the studs. And for the walls of the false ceiling, which face a wall or a ceiling, I insulated them with 3 cm polystyrene. All this information is in Aldes's technical documents. I'm not inventing anything. After insulating your structure, just finish it with standard drywall panels. The finishing coat you apply before painting will complete the ceiling. But before that, you'll need to cut the drywall to install the metal counterframes that will hold the ventilation outlets. Remember to seal the counterframes with glue for watertightness. And finally, we run 2G 0.75 cables to connect each ventilation outlet to the central unit inside the house. We wire the outlet and snap it onto the counterframe. This false ceiling project is actually easy to do. And I'm telling you this even though it's a container house. I don't know if you noticed, but the walls are wavy. They're dented because they're used containers. In short, every project is twice as hard because it's a container house. But in your case, if it's a traditional house with straight walls and it's built by a professional, there's no reason to be afraid. It's really a very simple step. Now that our supply plenum is done, we can install our indoor unit in the closet we built specifically for it. This unit has a small black collar above it that distributes air into the suspended ceiling. We can run the cables for the air vents inside the collar and connect them directly to the indoor unit. We can also connect our wireless kit, which will allow us to control our heat pump remotely using our smartphone. On my indoor unit, I will then connect a 3-core 1.5 mm2 cable, which I will link to my electrical panel on a 10 amp circuit breaker. That lets me power my indoor unit. Next, I connect another 4-core 1.5 mm2 cable to communicate with the outdoor unit on my roof. And finally, I prepare the refrigerant lines so that a professional certified by Aldes can come and do the final connection. Last step, the outdoor unit. You can place it on the ground or on a flat roof like I decided to do. We're going to power this outdoor unit with a 3G 2.5 cable connected to a 16A circuit breaker on our electrical panel. And all that's left is to connect the 4G 1.5 cable that we ran from our indoor unit so that both units can communicate with each other. I always leave the refrigerant pipes placed next to it, waiting for the technician certified by Aldes to come and connect them. And once that's done, he can provide me with a commissioning report and allow me to use my heat pump. In conclusion, the heat pump is highly efficient and especially convenient to use for heating and cooling. Combined with a solar panel system and very good insulation, it's the solution to lower your environmental impact and, most importantly, reduce electricity bills. As for the duration of the work, let's say it took me about a week to do the false ceiling. But keep in mind that I'm not a professional and it's a container house, so it's a hassle. And it took me about 1 to 2 days to install the heat pump, make the connections, and figure out how it works. So really, if you're a professional or if you're a homeowner who hires a professional, it's a job that doesn't take a huge amount of time either. I hope this video helped you see the benefits of a heat pump, especially the T1R from Aldes. The references are in the video description. If you have any technical or general questions, feel free to ask them in the comments. The Aldes team and I are ready to answer you, so take advantage of it. And if you're interested in my thermodynamic water heater solution combined with my ventilation system, I invite you to subscribe. We're releasing a video on the subject in September. It's really a very interesting water heater. I'm really looking forward to showing it to you, seriously. And there you go. I wish you all the best and lots of luck in your projects, lots of courage. See you very soon on this channel.